Good evening, all. I hope you all doing well. We'll start for the day. Shashank sir, good evening.
Good evening, ma'am. Can you hear my voice?
Yes, yes, sir, you're audible. You can start for the day.
Sure. So let me share my screen. Give me a minute. Okay, fine. Let me share. Let's share. Yeah, I think you can see my screen now. Great. So let us start the today's session. So in today's session, let us discuss first about the linear regression part, and then we'll go to the logistic regression, and then from there let us take it to the decision trees and all those aspects. And one more important thing is to understand, there are certain concepts in decision tree, which is have to be started particularly. So before that, we'll go to this linear regression and logistic regression. So that is one thing I wanted to, just give a brief outlook, because the two very important algorithms like linear and logistic play a very important role, particularly in the field of analytics, right, and machine learning. So now let us start with what is linear regression first, right, and then we'll go to the logistics part. Okay, so this is today's agenda, and along with that, we also will do a practical part as well. Okay, so we'll do the practical part as well, and using a data set, we will try to build a linear regression model, and then we use two different data sets, one for linear and one for logistic. So this is what the agenda is about. So now let us try and understand that. Before that, anybody actually has any questions with yesterday's session? Maybe you can ask for a couple of minutes, and then maybe we can start. So so any particular question, if you have, you can ask. Because just before I go with the flow, maybe you can ask something which you want, you have any doubt from yesterday's session or something like that. Sorry. Okay. I think nothing much. I think I can go with the session, I guess. Fine. Okay. So let me start. Apart from, cannot see anything. Okay, fine. So again, I'll take some time, and again I'll come back to the questions part. Okay. So let us see what is a linear regression first. Okay. So talking about a linear regression, basically, there are two types of things when it comes to linear regression. One is the word regression and the word linear. Okay. So it is basically a combination of two words. One is linear and one is regression. So what is the need to put these words together? Okay. So basically regression is a statistical term. Okay. So and linear is basically a mathematical term. Okay. So why, these two have been put together and why we are using a concept such as linear regression, uh, you know, in statistics or, in advanced machine learning or machine learning. So what exactly happens in machine learning? How is it related to that of the linear regression? So now let us understand what is regression first. So regression is nothing but coming back to the original. That is what the definition of regression. Okay, so you'll never see this definition anywhere. Okay, so people might be mentioning linear regression is a concept where it is used to predict a dependent variable when it's a continuous. All these definition you see, but regression is something where coming back to the original form. That is why it actually is able to build a relationship between a independent variable and a dependent variable. So but there is a one clause when it comes to the linear regression pattern. So what is the clause when it comes to linear regression is we are talking about the linear data. So what exactly is linear? Let me go to a picture here. Okay, so here you can see one picture, right, which shows a line, right, which shows a line. So what is this line about, right? So it is a line which shows the relationship between the independent variable and the dependent variable. So here you can see that apple quantity and price. So here, what is the independent variable? The quantity of apple, which is on the x-axis, right? So here, and the dependent variable is the price. So based upon the quantity of apple, right, the price of apples will increase or decrease. So now if you are able to plot this particular, data on a graph, right, you'll be able to see a line, right? So a straight line, right? So if you're able to see a straight line or the data is in the form of a straight line, right? That is in where we call it as a linear regression. Okay, so that means we are able to plot the values in a straight line. Now coming back to the what we are discussing here, basically what linear regression does is it helps you to predict a certain value. That is what your dependent variable. So when I ask people what is linear regression, they say relationship between, right, between the variables. That is not exactly correct, right? Sorry, that is not exactly correct. Why? Because relationship between two variables is called correlation. It is not regression. Then why we are saying that we are talking about the relationship inside a linear regression? Please understand, correlation is always calculated between the independent variables. So when you calculate the correlation part, you always calculate it for the independent variables. So this doesn't mean we calculate for independent and dependent variable. We don't calculate. you know Predicting or building the relationship between a independent and a dependent variable is what regression actually is. So we always try to build a relationship between two independent variables, that is called as correlation. So when we are trying to build a relationship between a independent and a dependent variable, that relationship is called as regression. Okay, so this is, I think now you would have understood what is exactly regression. So first important thing is to build the relationship between the independent and the dependent variable. That is one very important thing you have to understand in regression. Then comes the prediction part. So, okay, fine, you have built the relationship. Then what's next? Then you apply this independent variable to predict the outcome variable or the target variable or the dependent variable. That is what linear regression or regression analysis actually does. So, we have seen, a straight line example also to depict or to understand that what is a linear regression, right? So this regression line or this straight line is in the form of something called as a y is equal to mx plus b, or you can also say mx plus c here. Okay. So let us go in little more detail. So here you can see that y is the dependent variable and m is the slope. Okay. So what exactly is slope in very small terminology is the rate of change in both the variables is called as slope. Very easy to understand. The rate of change. The rate of change in both the variables. That is why we take the slope formula as y2 minus y1 divided by x2 minus x1. So I think this you would have calculated in your school days, right? So why we are talking about, this now? Because it is part of regression. The regression line, what you build, which is in the form of y is equal to mx plus b, what we are calling now, in the, I can say statistics or machine learning terminology is in the form of not yx mx plus b, but we are calling it as y is equal to beta naught plus beta 1 x plus epsilon, right? So epsilon is nothing but the residual, or I can say error term. Okay, so actually residual is a proper a way of determining what is the epsilon. So b naught beta naught is nothing but the intercept. Okay, so nothing but the intercept, which is the intercept on the y axis. Okay, so it is basically where our line actually starts, or where the particular value of, where the y starts, right? So where the particular value of y starts, that is what is called as the intercept. And whatever the rate of change is in the values of x and y, that is denoted by using the formula, or for the slope formula I can say, which is y2 minus y1 by x2 minus x1. So that is what basically the slope is about. So let us go a little forward. So now let us understand that what is a multiple linear regression. So we have seen what is a simple linear regression. So simple linear regression to multiple linear regression, the only difference is having more independent terms, right? So in these, simple linear regression, you can see, right, just beta naught plus beta 1 x. That means there is only one independent variable. But when it comes to the multiple linear regression, you can see multiple terms, right? X1, x2, so on till xn. That means there are n number of independent variables which are actually put together to, to predict the outcome variable, which is the dependent variable. So here you can see in this, picture that there is something called as a loss function. Okay, so here you can see that h theta of xi is basically a value of x, which is the predicted value of x. Okay, so h theta naught of x is basically the function which is implemented using the independent variables. Okay, so that is what the basic nature of error function, or you can say the hypothesis function. Okay, let us not go much into, I'll try to make it very simple as possible. So there is also something called as a cost function. So what does the cost function basically does is it will try to predict how much of the difference between this actual predicted and the actual value. So it will try to sum the difference between the predicted and the actual value. Okay, that is what the cost function is. So just the difference between the predicted value and the actual value is called as the loss function or the error. Okay, so if you try to sum it up, then it becomes a cost function. Now, let us go to the assumptions of what is linear regression. Okay, so there are certain assumptions when it comes to how we are going to, how we are going to, move forward with the linear regression part. So, very, very important condition is that when you plot the graph, when you plot the points on the graph, the most important thing is they should have a linear relationship. That means a form of a straight line. So here you have seen, no, so something which is in the form of a straight line. So this picture or this picture you can see, right? So something which is in the form of straight line is basically called as a linearity or linear function. So something if you're able to put as a straight line, right? So now next condition is the condition of independence. That means the independent terms should be, or I can say observations, or I can say records. They each particular feature, okay, let us say independent variables as features. So the independent variables or features should be independent of each other. They should not have much of correlation between them. Okay, so next is the homoscedasticity. Okay, so I think for a few people this homoscedasticity, multicollinearity, these terms might be new to them, right? So let us keep it very simple to understand what is this homoscedasticity. So this is basically the variance in the residuals is constant through all the independent variables. So for example, here the residuals is nothing but the error term. That means, even the error term, right? Even the error term should be constant across all the, lines, regression lines which are built upon. So even this is very important when it comes to the homoscedasticity, okay, or the condition of homoscedasticity, where you have to build a linear regression line. Even even the regression, even the residuals, right, or the error term should be constant, right? Their variance should not deviate much. So even the small critical point is also very important to build a linear regression line. So next comes the this is even more aggressive point. Fourth point is the residuals, or I can say the error terms, should be normally distributed also. So what is normal distribution? Normal distribution states that the data should be in a symmetrical form. So that means the data should be in a symmetrical form, right? Or the symmetry, right? In the shape of a bell-shaped curve. So even the error should be normally distributed, right? So it's a very typical condition, correct? No. So this is how the assumptions or the criteria will be there for a linear regression. So next comes the multicollinearity. So multicollinearity tells you that the terms which are the independent terms, sorry, the independent terms should not have high correlation between them. Sir, why? What happens if the independent terms are highly correlated? It will be very difficult for us to take a decision on which independent or which features play a role in contributing to the outcome variable or the the target variable. So to identify this, it is very important that the correlation between the independent terms or the features should be very less or no correlation. So that is very important. That is where the correlation concept comes into the picture. Okay. So next, let us talk about the regression coefficients. Okay. So as we already have seen, right? So one is an intercept and one is a slope. So we already also have seen about the residuals. So residual is nothing but the error term which is left off. So next comes the R square. So while building a model, we will try to understand what is an R square. So if I show in the practical part, it is even more easy for you to understand. But in a simple term, right? So in a very simple term, what is R square? So R square is nothing but how much proportion, right? Or how much percentage, right? These independent variables are, contributing, right? Or example, if you say in a even more simpler term, uh, you know, how much dependent term is being explained or how much of dependent term is being relied on, right? So is what this R square tells you. So for example, if you're able to predict, right, and this value, right, this value of the R square is more, right, it tells you that the independent variable is contributing more to the dependent variable, right? So is it good or bad? It is obviously good, because what independent variables we chose, they are contributing directly to the dependent variable. So higher the score of R square, it is better. So R square is a very, very important metric which is used to check the model evaluation. Okay, so next is the adjusted R square. So this is a very small change, which this is actually very similar to that of the R square, but it will try to adjust the predictors. So adjusted R square is also important, but the very important thing to keep in mind is about the R square. So next is the steps how we construct a linear regression line. So first of all, we have to identify the dependent and the independent variable. So then we have to identify the missing values. So in simple terms, we are calling it as data pre-processing, right? So we are scaling the values, handling the missing values, training, and testing and all those things. Then we apply the method OLS. Okay, so OLS is basically a method which will try to, estimate the coefficients. Okay, so OLS is nothing but the ordinary least squares method. So then we use the techniques like, MSC. I think yesterday we have already understood that mean square error, and we also have a root mean square error as well. And then obviously our R square is always there. So then we try to understand the results, and then we try to predict the fit value. Okay. So now let us go to the applications part. So since our linear regression is a concept where it tries to predict the continuous variable or a numerical variable. Forget about the word continuous variable. Maybe you can, in a very simple term, you can remember it as it is a numerical value, right? So that is why you can say, examples like, predicting the sales, right? Okay, so the outcome you can, based on the clinical measurements. For example, how do we measure? And then, how much of heart rate can be there? How much of BP can be there? So any numerical value, right, we are able to predict using the data that comes under linear regression. For example, if it is a, any, something which is not numerical, a classifier, right? Then we have to use the classification methods, right? So next comes the finance sector, where we can predict the stock prices, right? And then prediction of temperatures and so on. So right, so coming to what are the advantages of using a linear regression, right? So it is very simple and easy to interpret, right? So that is extremely important when it comes to the linear regression part, right? So next is, it is easy to interpret, and then very easy to calculate as well. You will also find it very easy when we start implementing, which we will do in a few minutes. So then it is works well for the smaller data sets. So why we are saying it is works well for the smaller data sets is because of this linearity problem. So we have to make the data linear, and then we have to apply the linear regression part, right? So not always this is possible, right? So that is why there is, some of the some constraints will be there applying the linear regression. So now let us see the challenges. So since the data, or not always it will be a linear part, so overfitting and underfitting has always been a biggest concern or issue when it comes to linear regression. And then we have this assumption of linearity doesn't satisfy much when it comes to the real world data, right? So next is, it is extremely sensitive to the outliers, right, or distortions in the data. So a lot of whether it might be anomalies, whether it might be you know uh, I can say anomalies, you can say maybe outliers, anything. So that will affect the linear proportion of what we are doing inside the data. So then comes the non-linearity, struggles to capture the non-linearity, because we already spoken about this, because the model is based upon linearity. So next comes the model evaluation metrics, where we are trying to assess the model's performance. right? And then we have to understand how well the model actually fits. So now let us try and understand that why we are using mean squared error. Okay, so why we are using a metric called mean squared error when it comes to linear regression. So that is, this blue guy is asking, we are training using the mean squared error. It's a, nice pick, what I felt like sharing with. So then this green fellow is asking why we have to use the metric. Now let us see why we have to use the metric. Because, right, since these errors, okay, so since these errors are very sensitive to the outliers, okay, so these errors are very sensitive to the outliers. Please remember this. It's a very important concept when it comes to the linear regression. So since these metrics are very important to the, or very sensitive to the outliers, we are squaring it. Okay, that is why we are calling it as mean squared error, because there is a particular thing in the formula which is 1 by n summation. That means we are taking the summation part and we are dividing it by n. That means we are taking the mean, right? So we are doing the mean, then we are applying the squared part for the error. So that is why it is called as mean squared error. That's why it is named it as like that. So what actually it tells you is, it tells you the difference between the actual versus the predicted value. And after that, we are trying to square it and take the mean value. So we are trying to, we are taking the difference in the actual and predicted. So now imagine when you are taking the square and you are dividing it by the average, or no, you want to divide by n and you want to get the mean value. So ideally, we are calculating the error part. So what we want the mean square error to be very less, right? We want the mean square error to be very less. So if our mean square error is very less, because we are taking the difference between the actual and the predicted value. So you logically think ideally we want the difference to be very less, correct? No? So since the difference will be very less, that means our lower mean square error indicates that the model is performing very well. So that is why we calculate the mean square error. Very small value of MSE indicates that your model is actually performing well. So this is a very important criteria when it comes to the linear regression. So, next thing, next big thing comes is the root mean square error. Okay. So this is also very easy to interpret. Okay. So you need not worry too much about RMSE because this is just the square root of, mean square error. Okay. So obviously the lower value of RMSE tells you that the model is performing extremely well. Now let us go to the very important thing, which is the R squared. So now what is R squared? Right? So as I already discussed, how much of proportion that our dependent variable is being explained by the independent variable. How much proportion, whether it is 70%, whether it is 80%, how much it is being explained. This is what is R squared. So for that is why we have a measure, right? This measure is tells you, right? So basically, if you are having something above 80%, right? So something you have about 80%, that means it is a very strong explanation. Your independent variables are performing really well to contribute to the target variable, right? So it is between 60 to 80%. It is a strong, it is a strong, let's do. Okay. So, if it is between 60 to 80%, we are saying that it is strong. If it is between 40 to 60, it is medium. Then 20 to 40 is weak. and then 0 to 20 is basically very weak. Then, if you're having some 15-20%, right, it is a weak interpretation, right? So, your independent variables are not contributing much to your dependent variable, which is not good, right? Because you have taken those variables and you want to, predict your continuous variable and they are not contributing. That is very bad, right? So that is where the interpretation comes into play, and R square plays a very important role. Okay. So this is what the interpretation is about. So let us go to the metrics part now. So there is something called as a classification matrix. Okay. So, we have already seen the matrix which is used for linear regression. But let me also make you to understand that, there are some more metrics which are used for classification problems as well. Because as I already told that mean square error, root mean square error, right, R square, these are used for regression problems. But what about the classification? So classification has different metrics, right? So yesterday's session we have seen that also, something called as an accuracy, precision, recall, right, F1 score, right? What are these? Let us see what are those in detail. So basically, what is accuracy? Accuracy is nothing but the positive cases. So, I can say correctly classified. Okay, we should not say positive. That is different. We'll try to understand. There is actually something called as a confusion matrix. The table what you're seeing here is called as a confusion matrix. We build this confusion matrix for classification problems like a logistic regression. Okay, so we will build and I will show you also. Here, first of all, to understand what is what is this table, right? So there are four things inside a confusion matrix. Okay, so the name itself is confusion, so there is a little confusion part. So it's not that confusion, right, but it's very easy to interpret and understand. Okay, so we have to be very plain and thorough in understanding. Right. So now, in a simple terms, when we go into a project, we'll explain, we try to understand a little more into the criteria of what is a confusion matrix. But first of all, what is this confusion matrix is, there is something called as a predicted value and actual value. It is based upon this, and it has something called as a positive and negative. Now, what is this TP is about? TP is nothing but the true positive case. For example, I have classic, it's a positive case. For example, let us take a email example. So, for example, it is a non-spam email. Okay. And it is it is a non-spam. That means it's a ham. So it is a non-spam case, right? It's a genuine email, let us say. It's a genuine email. And my model predicted that it is also genuine. It's a true positive case. It is actually true and it is correctly classified. That becomes a true positive. So for example, it is a negative case. For example, it's a spam and the model correctly predicted that it's a spam. That becomes a true negative case, TP and TL. So the true positive case plus your true negative case divided by the total, which is true positive plus false negative and true negative. So if you add your true positive plus true negative divided by the all the others, right, you get the accuracy value. Okay. Now let us go a little forward. Yeah, I think I just explained you about accuracy, right? So now let us see first of all what is this false positive also. Actually, it is a negative case, and you predict it as a positive. For example, it is non-spam. Okay, but you predict it as a spam. Then it becomes a false positive. Now, what is actual is negative, and your predicted is also false, right? So it is again contradicting. That becomes a false negative. So clearly understand true positive and true positive and true negative are correct predictions. Okay. False positive and false negative are wrong predictions. Okay. Now, let us go to or let us understand what is a precision. So precision deals with the positive predictions. Whatever positive are there, you can say it is a precision. Let us go to the table. What are the positive cases here? True positive and false positive. Correct? No? It is irrelevant. Whatever positive cases are there, true positive and false positive. So if you add both of them, it becomes precision. Okay. So in that precision, you're only considering the true positive cases out of the true positive and false positive. Right? So next, let us go to the recall part. So recall actual positives is what recall is about. So it actually calculates about the TP, which is the what the precision does, divided by the false negatives. Okay. So next is the F1 score. So F1 score is basically a combination of both precision and recall. So what exactly? There's a small formula, which is 2 into precision into recall divided by precision plus recall. So this is, basically this F1 score is nothing but the harmonic mean between the precision and recall. So this is, basically used to balance out the metrics. Okay, we will see this, little more in detail also. Right. So now to make your understanding, I've taken one small box. Okay. So in that you can see that in the total 165, you can see the predicted, and you can see predicted no, actual no 50. Predicted yes, actual no 10. Actual yes, predicted no is 5. So and here you can see actual yes, predicted yes is 100. So for example, if you say what is your accuracy? So accuracy is basically the positive, correct predictions. Here you can see predicted no and actual no is a positive case, right? It's a negative and predicted correctly. So 50 plus 100 divided by 165 becomes the accuracy. I think somewhere around some 80%, something like that you will get. Okay. Now, before going into logistic regression, let us, let us do the practical part. Let me see any questions from anyone. So maybe I can share the data set as well. Check for questions. So let me just see. Yeah, I got a question. Yes. So correlation is shows the relationship between the variables, but it shows the relationship between two independent variables. So when you say correlation, right, that is what I was exactly telling you when we spoke about the linear regression part. We usually say relationship between two variables. That is absolutely wrong when it comes to correlation. Okay, so many people say this. Yes, I've even observed from my experience. Uh, you should never say correlation is a relationship between two variables. Correlation is always a relationship between two independent variables. That is the exact word. So, relationship between independent and dependent variable is what regression is. So this is one small criteria where people can adapt when it comes to discussing or describing correlation and regression. So In simple correlation in how two are connected when one changes the other. Yeah, that is actually, you're talking about the correlation part. There, if one changes in the if one value increases, the other value also increases. That is basically called as a positive correlation. So if one increases and the other decreases, it's a negative correlation. So if there is, they're completely scattered, there is no correlation part. So that is different. That is entirely using the correlation. Yeah. So anything else? Maybe. Um, okay. Please just ask, guys, if you have any questions. I'm just taking another 2-3 minutes. After that, I'll just go into the practical part. Uh, okay. Hmm, yes, I'll do that now in Anaconda. Yes, I'll be starting with that. So before that, one thing I can just share the data set as well. Just give me a minute. Um, okay. Just sharing this data set. So guys, you can download this data set. I've shared it in the chat. Yeah, I'll implement linear regression step by step and I'll show you. um, yes, with the data set. So overfitting and underfitting, is this important in training any model? Yes, it is very important. So it is very important when you talk about the overfitting and underfitting part. And one more thing is difference between ridge and lasso regression. They are basically used to they are part of something where you can actually fix the overfitting and underfitting part. So we'll come to that little later. That is also in our agenda and all. Okay. So basically, this ridge and lasso regressions are focused more on providing weights on the independent variables where where it it helps that variables not to overfit. So in that way, it is very helpful. Yeah. So I just shared the link to the data set. So I've shared the link. You can, just again, I'm sharing as well. I've just shared, guys. I think you can download it. I got one question stating that which model is best. Yes, it is very important that first of all you use the classification type of algorithms for classification problems, and for regression problems use a regression algorithm. First of all, that is one area you have to focus on. Okay, so for example, if you see, one small example I'll tell you. If you are predicting an outcome variable which is a numerical value, okay, so let us say what comes to our mind is basically linear regression, correct? No, so that is absolutely wrong. We should not just have a thought of linear regression. Okay, so not just the linear regression. Okay, so you can also think that you can also do the regression. Okay, so you can also do the regression, right, by using decision tree. Okay, so that also can be done. So now imagine, the thought process will change a bit now. Okay, so not just the linear regression. So we also can do the decision tree. Yes, you can do. Decision tree is capable of doing both classification and regression. So you can use the techniques in decision tree, which is built for regression problems. So, that is the kind of knowledge we have to build, when it comes to machine learning part. Then you'll be able to, I've shared the link, guys. Maybe you can, so let me just share it once again. Some people are not able to download. Guys, I cannot share the data set. I think I've shared the link. You can download that. Yeah. No, I'm not able to share the data set. So only the link I'm able to share. You can just download from that link. Okay. So let me start. I think I've taken enough questions. I'm not able to share the data set. That's what I just, yeah, that's what I was actually telling you. I've tried it actually, dragging and dropping and all. I'm not able to do. Just scroll it up in the chat. You can see the link what I shared. Yeah. Okay. So I think we'll get back to the the practical part. I think I've taken a lot of time on questions. All right, guys. I don't know why everybody's asking the same question. This this feature scaling, how does it improve? See, guys, feature scaling is nothing but building, bringing it on a same platform. Like bringing all the data into one zone where every variable will be on the, yes, that is what I'm, there is. Okay, so guys, please. So where you can actually bring all the variables on one platform, and so that because multiple variables have different values. For example, like salary, right? Simple example I'll give you. Let us not break our head too much, right? One small example I'll tell you, and then we'll go to the practical. Okay, please do not ask anything else apart from that. Okay, so we have to do the practical part also. So. See, listen carefully. There is a column, right? Or a feature called as salary. Okay. So now, if you see the salary, it will be like 50,000, 80,000, 1 lakh, 1 lakh 20,000, 1 lakh 50,000, right? If you see the age column, right, will you have, big numbers? Like, how do you have uh, you know, for salary, like age 50,000 years, will not have, right? We'll have, age 40, age 20, 30, 50, right? So, see the number difference between the age and the salary part. So, if you apply, this method, right? If you apply the method, what you are asking, which is the feature scaling or scaling of the data, this will bring down into the form of a normal distribution, which is in the form of 0 and 1, which is the, actual scaling what the normal distribution does. So because of that, because of that, they will be on the same level or the same batch. So now then it is easy for us to use it and use for the predictive part. Okay, so this is what the example is about. Okay, fine. All right, guys. So enough of this. I'll just share my data set. Okay. First of all, I'll just show the data set, and then we can, uh, you know, um, here you can see multiple charts. Share the link. Yeah. Here I'm sharing again. I've shared it again. Please just. Yeah, I got it. When you use R square or the mean square error, uh, we use both R square and mean square error when we actually, we want to test the model. After the model fitting or the first, we have to use. So it is based upon how, see, when we train and test the model, it is very important. First, we understand that how the model is getting fit. So, is it linear or not linear? When, if it is linear, fine. So if it is not linear, then we have to make the linear, data into linear. Then you can actually, so paste the link again. Okay. You'll be able to see. We can share the data set also. Let me open the chat once. Yes, I'm just trying this. Okay, thank you. So I've shared the drive link. You'll be able to download. Guys, please download. Okay. All right. So let me start. Right. So this is the data set. Okay. And you can see multiple attributes in the data set. Okay. Okay. Fine. One more chat I got. Thanks. Okay. Fine. Thank you. So the attributes are, the price of the uh, house, and the next column is the area. Okay, and next comes the number of bedrooms. Then you have the number of bathrooms. Then you can see the stories, how many floors it is, and then you can see whether it is near to the main road or not. And then you have whether the house has the guest room or not, and then whether it has basement or not, whether hot water heating is available or not, right? Yes or no. And whether air condition is available or not. And you can see whether parking, how many vehicles can be parked, right? And area, right? The facing preface area. whether it is having or not. Then it is the furnishing status. Okay, so whether it is semi-furnished, unfurnished, semi-furnished. So I think unfurnished, semi-furnished, and furnished. I think three categories will be there. Correct, no? Now, if you see carefully, this price is a numerical value, right? Area is a numerical value. Correct, no? You can see my. Okay, so area is a numerical value. Then you can see bedrooms as a numerical value. Then bathrooms is also a numerical value. Then stories is also a numerical value, right? And then you can see parking is a numerical value, correct? So there are price, area, bedrooms, bathrooms, stories, and parking. So these six, right? 1, 2, 3, 4, 5, 6. So these six are numerical values, and there are classifiers, which is main road, guest room, basement, hot water, air conditioning, parking, sorry, preface area, and furniture. So around seven, right? 1, 2, 3, 4, 5, 6, 7. Yeah. So seven, you know, seven attributes or features are there, which are or which come under classifiers. Okay. So always remember the data set will consist of both, right? Classifiers as well as, you know, or numerical values. Both it will consist of. Okay. So it doesn't have just one. Okay. So all the values will not be numerical or will not be classifiers. So, one thing we have to be understand, or one thing which we have to be, aware of is a data will be a mixture of both numerical as well as classifiers. I think I got a question. Yes. To active attendance, no, that is not possible. Uh, so attendance will be shared. You can just please wait. Okay. So let me go with the please, just because I just want to explain the data set first before we go into a break, and then after the break we'll discuss the coding part. Okay. So please do not ask any questions kind of right now, just for few minutes. So, yes, sir. Actually, you can also call as a categorical data. Yeah, you can use that term also, or a classifiers. For example, like a yes or a no, right? Here, I think all it's a yes or a no scenario, except this furnishing, except this furnishing status. Okay. So I think somebody has raised something. You can ask. Please just give me a few minutes. So except this furnishing status, here in this, they are categorized into three parts. One is furnished, semi-furnished, unfurnished. So here three categories are there. Okay. But for the other part, there are only two, whether it's just yes or a no. So it's a binary classification. So here you have a multi-classification. So this is about the data set. Now, what we are going to do is we are going to build a linear model, right, for the data set. We will use the linear regression part. Okay. And once we build the linear regression, we try to predict the house price. So here price is already there. Now what we are going to predict, right? Because it's very important to understand what are the independent variables and what are dependent variables. Here, I'll tell you one magic here. Here in this case, price is an independent variable. Price is also a dependent variable. This is the magic of this data set. Why? Because I've shared the link, madam. Can just I've shared. Please just download. Okay. Yeah. Okay, fine. Here, the magic is in this case, usually your independent data and dependent data or the target variable will be different, correct? But in this case, your independent variable is also price and your dependent variable is also price. This is the magic of this data set. That's why I like this data set. Why? Because both it is acting as both independent and dependent variable. Okay, that is what very important in this to understand first of all. Because when you look at the data set, the most important thing is to identify whether the data is, what are my independent variables first in the data set. So that is very important. That is why, I'm having this discussion first to understand the data first. Then we can, talk about how to build a model and all. But very primarily, first of all, we should understand what the data is actually telling us. What are my independent variables and what are my dependent variables or my predicted value, or you can say the target value. Here we are actually using the parameters and we are building a linear regression model. And this linear regression model actually is built. So then what exactly our target is? Our target is, right, based upon certain parameters, like for example, right? For example, like a certain parameters, like whether it is, when you pass a particular value, right? Such as area, bedrooms, bathroom, stories, right? And parking. How much price we can give for that particular house. For example, whether it is, 2 lakhs, whether it is 5 lakhs, whether it is 10 lakhs, right? How much amount, or 20 lakhs or 50 lakhs. So this is my criteria. So now we will use all the parameters to build the model and we try to predict how much of amount which we can give to that particular price. For example, you have a model which is built using the linear regression. Now, if we pass certain, even I show you how to pass an unseen data and how you can predict, right, how much price your model is able to give for that particular, you know, data which you have passed. Maybe it is having some 3 bathrooms, right? It may be having some 2 bedrooms, right? Or it might is having only 1 bathroom, 3 bedrooms. It might be any kind of data. The area might be, 4,000. The area might be 6,000. It might be data, whatever we are training on, right? So we give a certain parameter and we try to predict how much of price that we can give for the house. That is what our prediction is. So here, when I'm saying I want to give or I want to predict how much of price I have to give for that particular house based on some parameters or features. So now all these things are given. I'm predicting a numerical value. That is why it becomes a regression problem. Okay. So this is what about the data set is. So now, let us take a very short break. Okay. So maybe 5 to 6 minutes. I'll come back fast. So yeah, I think I got a question. I've shared the data set, ma'am. Yes, I'll just share again, sir. Maybe you can just have a down. If you have not downloaded, you can download it now. Okay, guys. So just tell, go for a quick break and come back. We can, discuss about the coding part. Right. So we'll guys, I've shared the link. You can just download from this link. I've shared the link again, guys. you know. Okay, fine. So those who have not downloaded, you can. I've already done it, Arif. Oh, okay, I'll post it again there. Maybe I think it's not allowing, I guess. Okay, fine. Let me continue. Okay, let me share my screen. Guys, please let me discuss the project part, please. Let us try and understand things. Okay, so let us start with the Python part. Okay, so the first and the foremost important thing is to pull in the required libraries. Okay, so pulling in the required libraries is the very important part of starting with the dataset part. Okay, so when you have to do a project, the most important thing is to pull the you have to pull the libraries first. Okay, so here I'll take the chats and all later, please guys. Just give me a few minutes. Okay, so please. Okay, so let me fine. So the first important thing is to import the required libraries. And first of all, we have to understand what are these libraries first. Okay. So I'll explain it in detail, then we'll move forward. Okay. So the first library is nothing but NumPy. Okay. So NumPy is basically used to read the arrays. Okay. So NumPy is full of all mathematical calculations. Okay. So basically NumPy is nothing but numerical Python. So all the mathematical formulas, applications, and reading of an array. How to read an array, not just one dimension or a two dimension, but a multi-dimensional array. So for that, we use the NumPy. Now, next thing is the pandas. So pandas is basically used for reading a data frame. Okay. So pandas is basically used to read a data frame. So we are importing NumPy as NP. NP is nothing but an alias name. And the same thing for pandas as well. So pandas, we import it as PD. Okay. Next, we will see Seaborn. So maybe, yeah, first we'll go with the Matplotlib. So Matplotlib is a data visualization library. Okay. So Matplotlib is implemented or it is imported into the Python by, the alias name as PLT. So matplotlib.pyplot as PLT. This is what the name what we use. So next is the Seaborn, which is, as SNS. So that is the alias name for Seaborn. So Seaborn has, little advanced visualizations compared to Matplotlib. Now let us go to the very important data set is data set is the same as the data frame. Yes. Yeah. So you cannot directly import the data set. To improve the data set in the form of a data frame, which is in the form of rows and columns, for that we need pandas to import the data set as a data frame. Right. So let us next see the libraries which are very important to build a model for linear regression. So the very important libraries or modules or functions which are used. So here you can see there is only one library which is sklearn. So sklearn is nothing but scikit-learn. So scikit-learn has all the machine learning algorithms in that particular library. So in that we have something called as a model selection. That's fine, no? Okay. So here you can see that we are importing the library, which is sklearn. Okay. And in that we have the modules, which is model underscore selection and linear underscore model and metrics. Now, please understand there is something called as a function, module, and a library, right? A group of functions is called as a module, and group of modules is basically a library. Okay, so this is the pattern. Okay, so to install sklearn, you can use the function pip install. Okay, and library name. Okay. Okay, so pip install and library name. Okay, we have to use. Yes. Okay, so now coming back to the project, here you can see that this model selection is a module. Okay, linear model is a module, right? So you can see train, test, and split. This is a function. Linear regression is a function. Mean squared error and R square is a function. So these are all functions. So linear regression is inside the module linear model. Okay. And this linear model module is inside the scalar. This is how you have to understand this. And as we already have discussed in the theoretical part, we are importing the linear regression because we are building the linear regression. And then you can build the mean squared error, or it's a metric, right, to measure the accuracy of the model, right? And we will also test it on a unseen data as well. Okay, so we are going to use the two metrics. One is mean squared error and the other is the R square. So, regarding this, we have already have discussed. So I'm not going to, again go with this. Okay, and this is a function which is very important, which is for the model selection, where you train, test, and split the data, right? So we already have also discussed on this that, usually 70-30 or 75-25, right? 70% of training data and 30% of testing data, or 75% of training or 25% of testing. So like that, we divide the data into training and testing. Okay. Now let us go forward. Now the next important thing is to read the data set. Okay. So here we use a syntax called as pd dot read underscore csv. So this is a very easy syntax to remember as well. So here, when you use the syntax pd.read underscore csv, so pd indicates pandas. Okay. So df indicates the data frame, and read underscore csv is the function which is used to read the data set. Okay. And you can take the data set by, going into that data set, right clicking it. And, first you have to download the data set, since I shared you a drive link, and then you can actually use it as copy as path. Okay. So if you use copy as path, okay, you can actually import the data set. You can just have to put the address of the data set here. Okay, so this is my address. Okay, you cannot use the same address. It is my laptop's address. So you have to put your address of your data set, where is it in this format? Usually when you take copy as path from Windows 11, you will usually get a right slash like this. Sorry, you'll get a left slash. Yeah, sorry, you'll get a left slash. But you have to remove this left slash and you have to put a right slash. Okay, you have to put a right slash. You can see here that all these slashes are right slashes. Okay, so let me take up questions. Yeah, I've already shared the data link data set again. I just shared it again now. Sorry. Yes, if the library is not existing in your, if it's not existing in your, I can say, wait, let me edit. Sorry. Huh. See, guys, let's see this. If that particular library is not existing, you can use this pip install, for example, like NumPy. Okay, so if you use this pip install NumPy and you hit that run button, okay, so the important thing is it will run. Okay, so the library will be installed. You need internet to install the libraries. Okay, and if library is already existing, it will show or pop out this message stating that requirement already satisfied. Okay, so if it shows this, fine. Okay, if it is not there, it will automatically install. Okay, and one more thing is you need not worry about something called as reinstallation. So for example, if your library is already existing in your Jupyter notebook, right, it will show that requirement already satisfied. It will not again reinstall. It will not do that. Okay, so only once it will install into your laptop. You can implement in Google Colab also, but one advantage. But one advantage is when you implement in Google Colab is you need not install any libraries. That is one advantage what you have in Google Colab. You need not install any libraries because Colab already has libraries embedded into it. Okay, so automatically it will automatically run. For example, it's whether it might be NumPy, Pandas, or Scikit-learn or Matplotlib, any library, right? It is already existing inside the Colab environment. So that is one advantage what you have when you use the Google Colab. Okay, so this is one thing I just wanted to tell you. So here you can put the library name, right? Pip install and library name, and you can run the code. Okay, so let me remove this. Let me go with the project. So now here, you can see that I have mentioned the necessary libraries. Okay, so here I've imported the NumPy, Pandas, Matplotlib, Seaborn, and all those whatever are required for building my project. Now let me go down where you can see the data set, right? So you can take copy as path, and if you take the address, you will get a left slash. As I already told you, you have to change the slash to right slash. Okay, always remember you have to use the right slash inside the dataset address. Okay, in the Python to read the data. Okay, now let us go forward. Next part is df.head. Here you can see df, right? So what is exactly df here? It's a data frame. Fine. It's a data frame. But what exactly is df? Df is a variable here. A data frame. Yeah. Yes. So it's actually a variable. Okay. So it's actually a variable. Okay. So now you can use this variable to read the data set. Okay. So if you run df.head, what does it happen is head function here will give you the first 5 observations in the data set. Okay. So head function gives the first 5 observations in the data set. Since you can use any variable. Okay. You can, instead of df, you can, give any name. Okay. It's up to you which kind of variable name you are going to give. But you have to use that variable name wherever you want to apply the functions. Okay. Now, the next thing is if you run the head function, it will display the first 5 observations in the data set. So this is the data set which I already showed you. So next is the function which is shape. So shape is nothing but the how many rows are there, how many columns are there in the data set. So here you can see that there are 545 rows or records in the data set. And there are 13 columns in the data set. Now, next thing is the describe function. This is a very important function. So what is this describe function is? Describe function actually gives you the very important statistical summary. For example, it gives you the count of how many observations are there. And please remember, describe only describes the numerical part. Okay. So here, when we have seen the data set out of 13, right, variables or features, you can see that there are only 6 numerical values. So price, area, bedrooms, bathrooms, stories, and parking, right? So since, as I told you, it's a statistical measure. So statistical measures always works on numerical data, correct? So it will only calculate for the numerical data. So that is why instead of getting for all 13 features or variables, we have only got it for 6 because there are only 6 numerical variables. Got it? This is a very important thing you have to understand. Now, what does this describe function give? Now we understood why only we got 6. Okay, done. Now, what does this describe function gives? It's basically, as I told you, it's a statistical summary. Now, what does it give? It gives the mean value. It gives the standard deviation value. It gives the minimum value. It gives the percentiles, whether it is 25th percentile or 50th percentile or 75th percentile. So percentiles, 50th percentile is nothing but the median value. So, and then it gives the maximum value. So it gives basically the statistical summary of the data. That is what the describe function actually gives you, or that is what actually the describe function tells you. Okay. So it is basically describing the, right, what it is describing. It is describing the statistical summary in the data. Okay. So this is what the functions are about. Now let us just see any quick questions. Okay, I think questions, I guess. Yes, we can only see the top 5 observations when we use the head function. So head function is basically used to see the top 5 observations, and tail function is used to see the bottom 5 observations in the data set. Okay, so top 5 and bottom 5. Yes. So any other questions? Sure, I'll share. I'll share the prediction part. I'll share you the notebook. Yeah, IPON build file. I'll share you. So see guys, see this head function and tail function is just to see whether the data is being read by the data set or not. It is just for that. Okay. So you need not want to see the middle of the data, this point, that point. You can give by an array form. You will get the, yeah, you can give first 10 observations. You can give first 20. Yes. Not really. We can, we can view the top 5, top 10, top, no, NumPy and Pandas will be directly there in the Jupyter or Anaconda Navigator, basically. If you're not having, usually it will be pre-installed. So if it is not installed, maybe you can install as well. Yeah. So, just coming back to the question, what people have asked. So you can actually, get back to the, first 10, first 15, first 20 observations as well. In the bracket, you can give 10. In the bracket, you see, no, df.head, and I've put a bracket, no. In that bracket, you can put 10, 15, 20, whatever number you want, it will print. Yes. Yes, like that. Yes. Yeah, it will print. Okay. Yes, same goes with tail also. Okay. So let me go back to the project part. Okay. So describe function gives the statistical summary of the right. It gives you the statistical summary of the numerical values. Now let me go to the next part is the columns. Okay. So this is a very unique syntax where if you just give df dot columns, we are going to get the columns of whatever columns we have in the data set, right? So, I think you'll be getting around some 13 columns, right? Because we have 13 columns in our data set. So df dot columns. So next is, yes, we can use that. Yeah. Yes, good, good. You have performed with XGP regression. Yes, we'll do that also. Using all the ensemble techniques also. I'll teach you those also. Okay, fine. So the next function is, the price function. I'm just finding out how many unique values are there in my price function. Okay. So if I sum all the price, okay, I'm totally getting a sum of, total amount of how much is there in the sum function. So here I can see all the unique values, right from unique function gives, for example, the price of a house may repeat. For example, you can have a particular, two houses, maybe pricing 20 lakhs or maybe some 30 lakhs. So this unique function gives you the unique values in that particular price column. For example, the same you can apply for also, for example, like bathrooms. Okay. So if you apply for bathrooms, it will also give, right? So how many, maybe I'll just, show you as well. Wait. Okay. Right. So it will compile. Oh, I have to read from starting again. Okay. Fine. Let me read. Fine, fine, fine. So let me get this one. We'll talk about that later. Okay. Now see, total, 10 bathrooms. So the same thing, you can just also apply the, by removing the, sum function also. So I see, for bathrooms, it has come. So, you can see that there are four kinds of, bathrooms. The houses with single bathroom, two bathrooms, three bathrooms, and four bathrooms. So we don't, by this unique number, you can identify that our data set, you know, doesn't contain a house without a bathroom. Okay. So it may sound silly, but it doesn't contain. We can come to a conclusion. See, okay. And we can also understand that the maximum bathrooms in our data set is four. We don't have more than four, right? So like that, you can identify for any for parking, right? You can take for parking as well, right? You can check here. See, for parking, you can check that, since it is parking, you can also have zero. So you have a parking space where you can park zero vehicles. That means no parking, one vehicle parking, two vehicle parking, and three vehicle parking. So that is the maximum what they have for in the data set. Okay. So this is what a small example where you can check the uniqueness. This is very important. For example, I've shown the bathroom scenario. It's very important kind of. Okay. Now let us go into the detailed part of the project, and coming to maybe this sum function, not that required. We can skip this. Okay. So now let us go to the next part. Okay. So now let us check this condition. Okay. So what is this condition about? So we are going to check for the condition where there are, any numbers which are, some infinite numbers, right? Maybe I can say it is a wrong entry, right? If we give this particular function np dot infinite, right, with positive and negative, this function will actually replace something which are having some infinite numbers. For example, the entry has not been done correctly, right? So if the entry is not done correctly and there are some infinite numbers in the data set, that will be replaced by NaN. That means the value is not available. Okay, so this is a very small function which we usually apply particularly for numerical values when we are actually predicting a numerical value. Then we will go with the dropping of the empty columns, so empty rows, right? So here we use the function drop NA. So drop NA gives the deletion of that particular rows. And now we are giving the column which is price. So since we are mentioning, right, the column price, it will drop any, right, if it will drop any non-existing values or empty values, right, inside that particular column. Now if you here you can see the word in place is equal to true, right? So this in place is equal to true indicates that whatever changes you make, that will be done inside the original data set. Okay, original data set indicates the data set which is brought into the Python, right? That means in the DF, the data frame. Okay, not in the Excel file what we have. Okay, don't get confused. So we are making the changes in that particular data frame. Okay, so now next is, this is purely optional. Okay, so this is one kind of style which I have set up. Okay, so this kind of style is actually will give you this grid lines. Okay, so this is purely optional. Okay, so I'll just put this as optional. Okay, if you want, you use this, right? So now let me come to the scatter plot. So one thing we have to understand, we can construct a scatter plot only for numerical variables. We cannot construct a scatter plot for a categorical variables or classifiers. So for which one, right? In our data set, you can see if I go back, right? So price, area, bedrooms, bathrooms, stories, and parking. These are the numerical values. So I can construct a scatter plot between bedrooms and bathrooms. Area and bedrooms, area and price, area and stories, bedrooms and parking, bathrooms and parking, stories and parking, and so on. So I can construct a scatter plot between any numerical value. Now I'm constructing a scatter plot for price and area. So if you see here, I'm constructing for price versus area. Okay. So what I want to see is how strong is my correlation between my price and area. So, if I want to see that, if I'm spending a certain amount of money on my house, right? How much of area ideally I'll be getting. So to understand this, I am actually plotting a graph. So what can you see by this graph, right? So what can you see from this graph? So we are using the hues as bedrooms as well, right? So number of bedrooms. Okay. So forget about the bedrooms part. So what kind of correlation can you see, right? So how much of correlation is there? So if you see carefully, right? So this is basically, it looks like a straight line, but actually it is not. Okay, so we cannot 100% say that there is no correlation between price and area, right? But it is also not perfectly correlated also, right? You can see a lot of scatteredness in the data, right? That is why we construct a scatter plot to see how much of correlation is there by the plot. So you can see there is a little positive correlation. I cannot say there is no correlation, right? But there is some positive correlation between them. Obviously, there will be correlated, correct? No, logically, if you think, the plot is also confirming that. But logically, if you think area is related to price or not, obviously it is related, right? Not every time. That is why they are not perfectly correlated, but they are correlated in some sense, right? Now, let us go to the next part. Okay, so all this palette and all is about the colors, what we actually have. Okay, so let me go to, go a little bit down. Now, let me see the distribution plot of the price now. Now, I just want to, so see, logically, if you think, why we see the distribution of the prices, just let me know, right? Just let me know why we see the distribution of prices. Yeah, right? So, is it really required, right? Yes, it is really required. Why it is required? Because we need to understand whether our prices are, symmetric in nature or not, whether my prices are following normal distribution or not. So from the graph, you can see that there is little skewness in the data because the tail is longer to the right. So if the tail is longer to the right, you can see some skewness. Whether it is longer to the right or to the left, there is some skewness. Yes, this is a histogram graph only, but we call it as a distribution plot. In Python, there is something called as distribution plot, which, basically we construct using the histogram. Okay, right? But we call it as a distribution plot. Why? Because it shows the distribution of the data, how the data points are distributed when you put it on a graph, whether the data is, whether the data is in the form of, or it is following a bell-shaped curve, which is the normal distribution or not. To identify this, we construct a distribution plot. Yes, sir, you're absolutely right. You are using a histogram. So here, there are something called as the number of bins, edge colors, font size, all these things, the figure size. There are a lot of things which you can actually give. So this is the grid style. Whatever grid you want, this is purely optional. If you don't want a grid, you cannot, there is no need to give a grid also, right? And even this, color of the plot also you can actually give. So please understand one thing that, why we actually give this or why we build a distribution plot is to identify that how the data is actually distributed in the, whether how much of skewness is there. Skewness is nothing but the error in the data. Okay. So ideally, we want the data to be normally distributed, but that will never happen. Okay. So that will never happen when it comes to the real-time data. Now, let us go to the next part, which is identifying the count of bedrooms. So now let us plot, right, using the count plot. So count plot will, here you have used, Seaborn SNS to construct the histogram, which shows the distribution plot. Now, next thing is the count plot. So here you can see the count plot, right? So SNS dot count plot. So this count plot actually gives you the count of number of bedrooms of, the entire data set. So when I ran this count plot, I've identified that, 3 bedrooms, right? There are 3 bedrooms, right, which are actually the most in the entire data. So, if you see the plot is constructing 1, 2, 3, 4, 5, 6, which indicates the minimum number of bedrooms in the data set is 1. The maximum number of bedrooms in the data set is 6, right? You can clearly see. And the most bedrooms, right, in the data set is 3, right? And a little less is not a little less, more than half less, right? You can see 2, and you have also 4 bedrooms also in the data set. Okay, and you can see a little proportion of 5 bedrooms and even more little for 6 and 1. Okay, right. So next is, let us go to the count of the bathrooms. Okay, so already we have understood that, when we construct a count plot for the bathrooms, the most important thing what we found is, single bathroom house data is more, right? 2 is also there, right? 3 is also there, but very little. 4 is very negligible. Maybe, 1 or 2. I think maybe 1, the plot is not able to even detect also. So, but there is actually, I think 4, because when we ran the, I can show you here. I think we have ran it here, right? So yeah, I think I've deleted it. Okay. So, when I ran that, even 4 has showed. That means you have that in the data set. Maybe a 1 or a 2 cases where we have the, 4 bathroom scenario. Right. So next we'll go to the selection the relevant columns. Okay. Now for constructing a graph, the very important thing is, price, area, bedrooms, and bathrooms. So these are the 4 important parameters which we are considering here. Okay. And now we are creating a independent and a dependent variable. So here you can see that area, bedrooms, and bathrooms we are considering as a independent variable. And you can see that those 3 are clubbed into the x value, which is the independent variable. And y is clubbed as a dependent variable because the dependent variable will always be 1, right? So the price is the dependent variable. Okay, so next is the shape of the x, which is 3 columns which we are actually taking. So 545 comma 3. Now the important thing now is to train and test the data, right? So here, if you can see carefully, we are dividing the data. Here you can see that we have divided into x and y, right? The 4 important things are training and testing. Okay. So why I'm saying 4 is we have, for x we have 2 and for y we will be having 2. For example, for x we have training and testing. And for y again we have training and testing. Okay. Next, the function to define these variables is train underscore test underscore split. Okay. So train underscore test underscore split is the function. And here we are giving the variables and we are giving the test size as 0.2. So remember that if we give the test size as 0.2, that means the training data is 80%. Okay. The training data is 80%. So it is defaultly understood. Okay. So 80%. 80% training data. That means the rest 20% is the testing data. Here you have to mention only one. So if you mention training data or train underscore size is 0.8, that means the testing is 20%. So you need to mention one. Next is the random state. So random state gives the fixed sampling. So next we are building the linear regression. So we build a linear regression in the linear regression function. Okay. So now first we have to fit the model for the training part, right? So that is why we give both x train and y train. The test part, x test and y test is for testing the data. After the training, we have to test the data, right? So first we give the training part and then we'll go with the testing part. So first, how do we fit is, we fit the model into the training and, training for both x and y. Now, once the model has fit, because model.fit is the function. Once it is, fit into the data points, then we start to make the predictions for y. So what is the y here? It is the price. So for the data point, we start predicting the y. Okay. Now, on the testing data, we are trying to predict the values of y, which is the y predicted value. So here you can see some values which the model has predicted. Now, if we go down, there are very important things is the calculating the evaluation of the model. So the evaluation of the model is calculated by 2 things that we already have seen, which is the mean squared error. Sure, I will share the mean squared error and the R2 score, or I can say R square score. Okay. Now, if we run this piece of code, we have the mean squared error and we have the R squared score. So as we already have told that, lesser the R square, right? the independent variables are, here you can see only some 45-46% the independent variables are contributing to the dependent variable. Okay. Now, if you see carefully, coming to the next part, right? So when you build a linear regression line, it is not exactly in a straight line. See, the points are little scattered. Why? Because it's not able to predict properly because our R2 score is not that great. Okay. And even the mean square error is also very huge. This is the problem where you can see that the line is not built in a straight line properly. That means the data is not in a very good linear shape. Now, let us conclude by sending a data point. Now, we are passing one unseen data point. Here, we are passing the area to be 1500 and we are passing the bedrooms to be 3 and bathrooms are 2. Now, we are asking the compiler because we have fit a model that you can give me the price. So the price it has given like this, right? That 10 lakhs. So 45 lakhs is the price, correct? No? Yeah. So 45 lakhs. So if the area is around 1500 and the bedrooms are around 3 and the bathrooms are around 2, you can pay for the house, which is 45 lakhs. That is what our model is telling. Okay, I don't think our model is that very good accurate. Maybe, we need some more hyperparametric tuning and, we need those. So we'll see that, in the coming, we see that for the different algorithms also, how we, tune the parameters and how we, hyperparameter tuning, feature engineering, and all we do to, make sure that the data is, built, or you can say that data is trained well for the model. So that we will see in the coming sessions. So apart from this, this is what the linear regression is about. So I'll share the files. It will be uploaded in your LMS. You can just use that. So anything you want to ask, or we can conclude the session if you have any, if you don't have any doubts. So let me just check the charts. Yes, I'll ask the team to share. I'll share it with you guys as well. Yes, you will have. You can get it in your LMS. It will be shared. Yeah. Disease prediction, it's not the same because for disease prediction, it's a classification problem. So we'll do that kind of problems as well. I'll take from multiple data sets, multiple problems, multiple business scenarios. We'll discuss that step by step. Okay. So we have, yeah, it's a 30-hour program. We have so many of hours left. We have a lot of things to cover as well. Linear regression is just a, starting step of, model building. Yeah. So I think you can take over, Sushmita.
Yeah, sure, sir.
Yeah.
Yeah, so students, I will share the attendance link once again on the chat. Kindly mark your attendance as we are done for the day. So thank you, sir. Thank you so much for this wonderful session.
Yeah.
Thank you, students. Thank you for joining. So we'll wind up for the day. We'll meet again by tomorrow at 7 p.m. Okay. Thank you all. Good night.